Hi all, just a quick video on the latest on my time-lapse rail system. I haven't done anything on this in a long time, but I've gone back to it recently and kind of updated it so it includes a lot of 3D printed parts and CNC cut plates and stuff. So on the end you'll see, so it's made with off-the-shelf parts for gripping the 25mm pipes and so on, and I have a logo stuck in the other end. So, but the most interesting bit is what I want to show you today is the user interface and the change in electronics. I have the controller on the board opens a Wi-Fi hotspot, which I can connect to by going to my Openlapse, for example, which is a name I've come up with for the whole system. So once I connect into that, so I've successfully connected into the Openlapse hotspot, I can then browse to openlapse.local, and there we have the main menu. So the main screen looks like that. So I can say stop the time lapse. So the time lapse on the camera stopped moving. I have manual motor operation. Stop. Let me just turn that off and on again. The firmware problem with the motor driver, which I'm going to fix later on. So stop the time lapse. Okay, so manual motor, and if I go stop and right left and stop and so on, menu. Then for configuration I can change the pulse length, shutter, something a bit more often, like maybe 1500. Frame count, let me see, 30, and save that. So when I start my time lapse, then it kicks off. So my motor controller is gone again. That's a pain in the butt, but stop that. Okay. So with the camera off the dolly, and this is what it looks like. So let's have a look underneath and have a look at the new design. So as with the previous designs, there's the time-lapse motor, which has 3D printed parts and CNC cut die bond for strength. It's a very robust material, a few nuts and bolts and bearings and so on. The bearings for the rail are as per previous designs, which are just bearings on a 3D printed part at an angle that sits nicely on a rail. So we have a power supply here, which is basically an array of batteries. There you go. So that's bolted onto the bottom, so we can change in the batteries. Generates about 10.5 to 11 volts or 12 volts, depending on how the batteries are charged. And the interesting stuff, which is the electronics. So no screen anymore. Let me just see if I can focus that. So it's a custom board, and on the custom board there's standard parts, so it's quite a simplified setup. So what's on the board, what's on the carrier board, and I have one over here, is basically a WeMOS D1 Mini Pro, which is a Wi-Fi enabled microcontroller. So that's what generates the web interface and the access point, and it's what generates the signals, the PWM, or sorry, the I2C signals for the other board, which is a standard board, which is a motor controller, and that again is a WeMOS D1 compatible motor controller board. It's designed to sit on top of the board, but I thought aesthetically it looked better when they were side by side. And here's one of the custom boards populated. Here's one of the custom boards without the PCB, without any components. You can see there's the nice, I hope to call it Openlapse, and open source the whole system, hardware, software. and there's a populated board. So there's all the components. So we have on the board is a couple of transistors and resistors for the shutter and focus of the camera, with 2.5mm output there, which takes a standard cable, and the cable is a standard off eBay, which is a Canon 5D connector, or whatever camera you want to get. You can get the cable depending on the camera. 2.5mm socket jack, and on the board there's the socket there for that from the switches or the transistors. On the other side we have a DC to DC converter with output 5 volts, but it takes in anything from, I guess, 7 to 18 volts, and give you a nice stable 5 volts out the other side for the WeMOS controller and the motor controller logic, and then the batteries pass through directly to the motor. So if you want to use 12 volt 15 volt motors, that's fine. That's that. So it uses standard enough parts, so I was trying to simplify everything down so that all you need is to build yourself one of those, and you get the camera output and the motor outputs all on one board, and you get the web pages to control it, all in a nice small package that you can bolt onto the bottom of your camera dolly. And it's quite a simple circuit. So if I just switch it on, you can see there it's driving the motor. I have it set to go on by automatically when I switch it on, and then I can go into my, if I go into my Wi-Fi, let me just connect in again, switch hands. Let me see if this is actually working, if it's connected in. Submit, no, we're not connected in. Let me go to, let me go to Openlapse and let that connect. So that's connected, so then we're back onto Openlapse. Let's refresh the screen. Start the time lapse, stop the time lapse, okay. And then manual motor operation. You can see there. And if we go stop and left. Okay. And then you have advanced stuff like you can upgrade the firmware via Wi-Fi. You can configure the Wi-Fi hotspot, call it Openlapse. You can go back and just look at the information on the firmware and so on. It's based on the Sonoff software, and I cut it down, but there's some really good software in that. Theo Arends originally wrote the Sonoff software. Great piece of software, and I've based this on a simplified version of that. So I hope to open source this and get it uploaded over the next few weeks. Give us a comment or drop us an email if you're interested to try it out. Okay, cheers.